Dear students, in the previous class we discussed about the optical activity and the plane polarized light and all. This plane polarized light means the light which vibrates in only one direction, that we called as a plane polarized light. Then optical activity means this we have discussed in the previous class. Some of the organic compounds can rotate the plane polarized light either left or right, that we called as a optical isomers. The phenomenon is called as a optical isomerism. In this class we are going to be discussing about the some other terms, that is specific rotation. The specific rotation is going to be represented by this alpha, that is T and D. That is this about the representation of the specific rotation. Then what is meant by specific rotation? The angle of rotation of plane polarized light by 1 decimeter of the solution containing the 1 gram of substance per cm cube at a temperature T degree Celsius by using the sodium light. Is called as a specific rotation. The specific rotation means the angle of rotation of the plane polarized light. The angle of rotation of the plane polarized light by 1 decimeter of the solution containing 1 gram of the substance per cm cube at a temperature T degree centigrade by using the sodium light, that we call as a specific rotation. The formula used to find the specific rotation, that is alpha, that is concentration of this T is equal to theta divided by L into C. Here the wave here the theta is nothing but the observed angle of rotation, that is observed angle of rotation. L is nothing but length of column of liquid, then C is nothing but density or concentration of, that is density or concentration of a liquid. This is the formula to use to find the specific rotation. The specific rotation is equal to that is theta by L into C. That is the definition itself. It's going to be said the angle of rotation of plane polarized light. That is 1 decimeter cube. That is length of the is going to be measured in the decimeter. The length of the column of liquid in decimeter. We are going to take that in decimeter. That is the surface of the solution of a substance containing 1 gram per cm cube at a temperature T degree by using the sodium light. This observed angle is this observed angle of rotation is depends on the many factors. That is it's going to be depends on the nature of the substance. That is this observed angle of rotation is depends on the nature of the substance, nature of solvent, and the wavelength of light is used. Then the temperature at which measure and length of the solution, the length of the column of solution. These factors, this observed angle of rotation is depends on these factors, that is the nature of the substance, nature of the solvent, and the wavelength of light used, and the temperature at which the light is going to be measured, then length of the column of solution. In this class, now we are going to be discussing about the asymmetric carbon. Asymmetric carbon means that is two scientists explained about this asymmetric carbon. That is J1 of and C. E. Bell. These two scientists independently argued about the spatial arrangement of four atoms around the carbon atom is tetrahedral. It's going to be tetrahedral. The arrangement of that four atoms around the central carbon atom are different. That central carbon we called as a asymmetric carbon. That the central carbon atom is called as a asymmetric carbon. Suppose that the carbon containing at the center is going to be surrounding by the four different atoms. That is A, B, C, D, like this. Different atoms that we called as a asymmetric carbon. This asymmetric carbon is going to be represented by using the star mark. This we call as a asymmetric carbon. Asymmetric carbon means that is the carbon atom which is surrounded by the four different groups or atoms is called as a asymmetric carbon or chiral carbon or stereo center. We called as a stereo center. This is going to be explained by that is J1 and C. E. Bell. These two scientists have discussed about this asymmetric carbon. In this, the next we are going to be discussing about the enantiomers. So what is meant by this enantiomers? In the year 1848, there is scientist, that is one of the scientists, that is Louis Pasteur observed that some of the crystal compounds, that is some of the crystal compounds are mirror images. Means here Louis Pasteur in the year 1848 is going to be observed that crystals of some compounds are mirror images. Means a pair of stereoisomers. Are object as related as object and the mirror images. And non-superimposable. Then which can rotate the plane polarized light but in the opposite direction. That we call as a enantiomers. Enantiomers means a pair of stereoisomers are related as object and the mirror images. But it is non-superimposable on the other. Then it can rotate the plane polarized light but in the opposite direction. That we call as a enantiomers. Example for this enantiomers, when it comes to the example for this enantiomers, the 2-chloro-butane, then butane 2 all. This are example for the enantiomers. When it comes to this enantiomers, I said that these are example. How it's going to be example for this? We are going to be taken that carbon, there is a carbon at the center. Then this is the asymmetric carbon. That is a chiral carbon. It's called as a chiral carbon. Then CH2, CH3, then Cl, then CH3. That is the 2-chlorobutane. That is 2-chlorobutane. If you are taken the mirror, the another stereoisomer we can be written as, that is CH2 CH3, then Cl CH3 H. These are, you can observe these two stereoisomers. You can observe, this is the object, this is the mirror image. This is the mirror image. You can see that it looks like it is a mirror image. This stereomer is going to be looks like a mirror image of this. Then this, when we are going to be superimposed, it's going to be superimposed on one another. It's going to be non-superimposable. You can observe on the CH3, that is going to be imposed on that is the groups, the CH2 CH3 group means it is going to be non-superimposable, and it can rotate the plane polarized light equally but in the opposite direction. This we called as enantiomers. Enantiomers means the pair of stereoisomer related as the object and the mirror, mirror images and non-superimposable on one another, and this rotates the plane polarized light equally but in the opposite direction. That we call as enantiomers. Now we are going to be discussing about the characteristics. So, enantiomers. When it comes to the characteristics of enantiomers, these are going to be enantiomers shows the same physical properties. It's going to be shows the same physical properties. Physical properties means we are going to be taken as boiling point, melting point, and density. These are etc. This shows the same physical properties, but it rotates the plane polarized equally but in the opposite direction. This is the first characteristics of this enantiomers. When it comes to the second characteristics of this enantiomers, it shows the same chemical properties, but when it is it shows the differently react with the optically active compounds. Same chemical properties, but differ in react with the optically active compounds. Means here, when it reacts with the optically inactive compounds, it shows the same chemical property, but it reacts with the optically active compounds, it gives the different chemical properties. Then enantiomers are the biological, it shows the different biological properties. Say example for the dextrose sugar. We are going to be taken the dextrose sugar. Dextrose sugar is metabolized. Then that is dextrose sugar is metabolized, but levo sugar is not metabolized. Not metabolized. Then this is going to be levochloromycetin. Another example, that is levochloromycetin is against to the pathogenic bacteria, but is one another, that is levochloromycetin is active, that is against the pathogenic bacteria, but the dextrochloromycetin is inactive against the pathogenic bacteria. This is about the example for this. That is if the enantiomers shows the different biological properties. Then next comes to that the another characteristics that we are going to discuss. one of the important definitions so many times asked in the examination, that is the racemic mixture. Racemic mixture, that is equimolar mixture of, that is dextro isomer and levo isomer is called as the racemic mixture. The another characteristics of the enantiomers is, that is a equimolar mixture of, that is dextro isomers and levo isomer is called as a racemic mixture. In this class we have discussed about this three things, that is asymmetric carbon. Asymmetric carbon means the carbon is surrounded by the 4 different groups or atoms is called as a asymmetric carbon or chiral carbon, that we called as a chiral carbon or stereo center. Like this different names we are going to be calling this asymmetric carbon. Then enantiomers means a pair of stereoisomers related as object and mirror images and non-superimposable on one another. It can rotate the plane polarized light equally but in the opposite direction. That we call as the enantiomers. In the characteristics of enantiomers are, that is the body, the physical properties is same, that is body point, melting point, density are same, but the rotation of plane polarized light is different. The magnitude of specific rotation is same but in the opposite sign. Then the chemical properties is same when it reacts with the optically inactive compounds, but it reacts with the optically active compounds. It shows the different chemical properties. Then enantiomers shows the different biological properties. Means like that example I given, that sugar, that is dextro sugar is metabolized, but levo sugar is non-metabolized. Then this fluoro, that is levofluoromycetin is active against the pathogenic bacteria, but dextrofluoromycetin is inactive against the, that is the pathogenic bacteria. The next we are discussing about racemic mixture. Racemic mixture is nothing but equimolar mixture of, that is dextro isomer and levo isomer is called as a racemic mixture. Now we are discussing about the elements of symmetry. In the elements of symmetry, there are 3 elements of symmetry we are discussing. That is about the plane of symmetry, axis of symmetry, and point of symmetry or center of symmetry. One by one we are going to be studying now. That is, first we are going to be studying about the plane of symmetry. When it comes to that plane of symmetry, we are going to be taking some examples. That is the mesotartaric acid. The mesotartaric acid. When it comes to that mesotartaric acid, this is about the mesotartaric acid. In this, the imaginary line, the plane of symmetry we are discussing now, that is imaginary line which is passing through the molecule, it's going to be gives the 2 equal halves. Is called as a plane of symmetry, that we call as a plane of symmetry. The imaginary line drawn in the molecule is going to be gives the 2 equal halves. It's going to be gives the 2 equal halves, that we call as a plane of symmetry. Now we are going to be discussing about the axis of symmetry. Axis of symmetry means we will take the benzene as an example. We are going to be taken the benzene as an example. This is a benzene. If the imaginary, this is an imaginary line, imaginary axis. In the imaginary axis, the molecule in which the molecule is going to be rotates 180 degree, it encounters the same appearance. That we call as the axis of symmetry. Axis of symmetry means through the imaginary axis, the molecule which rotates 180 degree, which rotates the 180 degree, it encounters the same appearance. It encounters the same appearance that we called as a axis of symmetry. This we called as a axis of symmetry. The next we are going to be discussing about the point of symmetry or center of symmetry. By taking some example, I am going to be explain this point of symmetry or the center of symmetry. I am going to be taking some example, that is CH3, H, then CH3, H, Br. The name of this compound is 1,3-dibromo, 1,3-dibromo, 2,4-dimethyl, 2,4-dimethyl cyclobutane. The name of this compound is 1,3-dibromo, 2,4-dimethyl cyclobutane. In this point of symmetry, the point in the molecule, the line is drawn any direction. The line is drawn in any direction, and the opposite direction. It encounters the same group of atoms. It encounters the same group of atoms. Is called as a center of symmetry or point of symmetry. That we call as a point of symmetry. Means in this three you can observe that the plane of symmetry means the line which is drawn in the molecule is going to be gives the two equal halves. The two equal halves is called as a plane of symmetry. The axis of symmetry means the imaginary line. To the imaginary axis, the molecule rotates 180 degree. It encounters the same appearance. Is called as a axis of symmetry. Then point of symmetry means the point in the molecule. The line is drawn in any direction, and the opposite direction it encounters the same group of atoms. Is called as a, that is the point of symmetry or center of symmetry. If this is about the plane of symmetry, axis of symmetry and point of symmetry. If suppose the molecule in which having all these three elements of symmetry, that we call as a symmetric molecule. Symmetric molecule means the molecule in which having all three elements of symmetry. That we call as a symmetric molecule. Means the molecule in which does not have any three elements of symmetry. That we call as a asymmetric molecule. The molecule in which does not have plane of symmetry, that we call as a dissymmetric molecule. If the molecule having three elements, all these three elements of symmetry, that we call as a symmetric molecule. The molecule does not have these three elements of symmetry, that we call as a asymmetric molecule. The molecule which does not have the plane of symmetry, that we call as a dissymmetric molecule.